say. So. Top of the water for a second there. Alright, so we'll be talking about MongoDB and PHP. Question for you. How many of you are using PHP? And the rest is asleep, because I know how many people are asleep. How many of you are actually using MongoDB already? Okay, a couple. It's because this is really pretty much an introduction. So, if you're using it a lot, then you might not get a lot out of this, but that's all right. So, for people that don't know who I am, I'm Derick, I live in London. I work on the PHP driver for MongoDB at the moment, and I've done lots of other PHP things as well. So we'll be skipping quickly over this and go to the real things, because I'm probably a little bit pressed on time today. So what is MongoDB? It stores data. That's quite useful to know. But it doesn't store data in the traditional sense that a relational database does. It stores it in documents. So it is a document storage and retrieval engine. With documents, I don't mean Word documents or LibreOffice documents, whatever documents you type in your typewriter and stuff like that. But very blocks of data, that's what you store. And one of the key features about MongoDB is that you actually don't have to configure anything. That's true for running it as one server, but it's also true for running it as 100 servers. In those cases, you do need to tell which servers are there, but there's not a lot of configuration around. There's not a lot of things you can tune, or want to tune, or have to tune. So it is meant to be really simple to use, and I'll have some examples of that in a bit, of course. So each document is stored in a collection, and a collection is stored in a database, and that's stored in a database server. And a database server can be part of a replica set, and a replica set can be part of a sharded environment. I'll have a few slides of that, but that's for later. So getting started with MongoDB is really quite simple. You can download it, untar it, and run it. There's no configuration going on here at all. Well, I would suggest to have a quick look at where you store your database, because MongoDB likes using quite a lot of disk space, even though if you don't store so much in it. So if you're playing with it, expect to have like 2 gigabytes of data free to start with. There's a few options that can tell you to use less data, but default is like that. If you're using a Ubuntu platform, you can use apt-get, we have a repository for that. The PHP driver is not available through that yet, but we're looking at making that work as well. So to get the PHP driver going, which is maintained by Christina, I can't pronounce her last name, Christina and me, and it is supported by Tangent, a company that also makes MongoDB. So we have a properly supported driver. It needs a bit of work. Installing it goes with a tool called Packle. Packle is a general PHP packaging tool. Type in just Packle install Mongo. It will work most of the time. You might have to do different things in case you have multiple PHP installation, things like that. But standard platforms, this will work. Then you add it to PHP on that. Pretty simple to do as well. So a little bit about terminology. I already mentioned that we have documents, and for MongoDB there are JSON documents. So what you will send to the database server is JSON, but it's not quite 100% true, because JSON, stealing from JavaScript, doesn't have a very rich set of data types. They don't have the set of data types that we might want to store in MongoDB. For example, datetime objects. JavaScript doesn't have anything for that. Or JSON doesn't allow for that, really. So instead of JSON documents being stored in a database, we call something called BSON or Bison. I've not quite figured out what the preferred pronunciation for that one is. Which is binary JSON, which extends JSON, changes it to a binary protocol, but adds extra data types so that you can do more cool things with it. So each of those documents is stored in a collection, and a collection is the relational database equivalent of a table. So a document is basically a row, and a collection is a table. And then you have an index. It's pretty much the same as anywhere else where you expect an index. But one thing that MongoDB doesn't do is because it's not designed to do it, it's designed to have something called embedded documents, which means that it doesn't do join. So you can't run a query that goes over multiple collections at the same time. But that is not necessarily an issue, because we have something called embedded documents. Okay, I'll break out to PHP a little bit. Connecting to PHP, to MongoDB from PHP, after you've installed the extension, obviously, you instantiate a Mongo object. You can give that a connection string, but by default it will be localhost, which is basically what you'll be doing when you start playing with it. But there's a whole bunch of connection strings that you can use. You can just set a domain name, different ports, fully qualified domain names, but you can also give it multiple names. And you can give it multiple names in case you're using something called a replica set, which is more than one Mongo database instance, replicating to other databases. And by specifying more than one, you get high availability, because if one goes down, it just tries the other one. Well, it's a bit more complicated than that, but that's the general idea. And you can specify as many as you want. You don't have to, because it's clever enough to go discover with all the replica sets or replica set numbers. All right, so after you've connected, then accessing a database or a collection in a database is as simple as using the name, well, you access like a property on the database, right? So that we use the demo database here, and in there we have a text collection. Now this will work if you have not done anything. If you have started MongoDB, then this will work, because on the fly the databases and the collections will be created for you. The moment you insert a document, the database will be created and the collections will be created, which is very useful most of the time, unless you make a typo, because then you suddenly have the different databases. Just be careful with that and don't make typos, I would say. Alright, so the documents are Bison, binary JSON, and the documents are consisting of fields with values. The values don't have to be static values, they can be other documents, and this is something we call embedded documents. Every document also has a unique ID in the underscore ID field. This is an ID that you can set yourself, but if you don't set it yourself, one gets generated for you by the driver. Those IDs need to be unique per collection. If you try to insert a document with the same ID, then it will not work. So a very simple document that I have here is I have an ID field with object ID. This is the kind of things that get generated for you automatically. It has a timestamp value in there and a counter and stuff like that. And then I have two extra fields, my Twitter handle, or that's what handle stands for, and name. Those are fields, and you can insert this document. If another document has different fields, you can just insert that. There's no reason why multiple documents in the same collection need to have the same field. So this is why the schema is. So this is a very simple document, but you can also have embedded documents. So in this case, I picked my own ID. I just picked my Twitter handle, because it's nice and short. Again, the name field is similar, and then I have a talks field. And a talks field is an array of two objects. So this is JSON, this is the array thing, and then there's two documents, this talk and this talk in there. And this is stored in one document. And whenever you do an insert or an update on the document, that is an atomic operation. So if you want to do a query, then you can also do queries on the embedded documents in Mongo. So this is how you model relations in a different way than you do in a relational database, where you have to do joins to do this kind of things. Now, in some cases, totally depending on how you access your data, it might sometimes make sense to not have all the data embedded in here, because there's a limit on the size of the document. It can only be 60 megabytes in decent form. So in those cases, if you want to do queries with for multiple collections, you'll actually end up doing two queries. But it is not necessarily worse than trying to write complex joins in, like I said, documents. Alright, so inserting a document. Again, here I have my JSON document. Converting that to PHP is not very difficult. You just convert it to PHP syntax. So, however, JSON has arrays and objects. Arrays that don't have a key, whereas objects have keys and values. In PHP, this can all be done with an array. So the articles is now turned into an array, which it was in JSON as well. But each of the embedded documents are also arrays. Now, the driver actually supports you putting objects in there as well, and then it will automatically do the correct thing for you. So instead of having an array there, you can have an object of standard class, or one of your own document class, or own object classes. That will also work as well. Again, I make the connection and I insert the documents. And that's all to it. Now, in PHP 5.4, you don't have to write array all the time anymore, and you can use square brackets. If you're using MongoDB, you'll very much appreciate that. Because everything you do with the database goes through with this JSON structure. That is, inserting documents with also queries and updates, and everything is done with this kind of structure. And then not having to type array all the time actually saves a lot of time. And it makes the examples fit on my slides. So MongoDB supports many, many types. They're very much equivalent to PHP types with a few exceptions. So MongoDB has two integer types. It has a 32-bit integer type and a 64-bit integer type. Generally not too much of a problem if you're coming from PHP, unless you are on a 32-bit platform, which always includes Windows as well, even though you're in a 64-bit version of PHP on Windows. And then you have to do some tricks to get around storing large integers. Strings that you put into MongoDB always have to be in UTF-8. If you put in something that is not UTF-8, it will warn you. It will just not insert or update the document, really. So arrays and associative arrays, which in JSON is actually objects and associative arrays. No, the other way around. It's arrays and objects. You can also use regular expressions. Those are not things you store in the database, but it is part of the decent protocol so that you can do queries with regular expressions. In the same way, there is a Mongo code type that allows you to run JavaScript on the server while doing some queries. In case you want to store some images in there, then Mongo bin data is good for binary data, because it doesn't have the restriction of you having to use UTF-8 for that. So I already mentioned that every document needs a unique ID. So take, for example, the example that we have here. I have an articles collection, and what I'm inserting in there is an array using the PHP 5.4 syntax here. I have a name and an ID. Now, in the second example, I don't set an array, an ID for my document. And then you will see when you var dump it later is that it actually will add the ID to the object. So after the insert, your array will have an extra field with the ID in there. So there's no such thing as get last ID, because it will just modify the array for you. And then you get like this big block Mongo ID thing that is an object with this randomly generated string. So I've mentioned that the ID field has to be unique, right? So, however, if you would run this script where I insert the same document twice with the same ID, if you would run this, it will actually work. Oops, sorry. And it will not warn you or give you errors for it. But it will only insert one document because it has to be unique. In the default configuration, every update or insert or delete that you do, it does not tell you whether the operation succeeded. Whether that is a good idea or not, that's up for debate. I think it is not a good idea. You'd rather really want to know for sure what actually happened. And in order to that, there's a few options. And to show it in a very simple way is that with every insert, I insert a document, but you can also set options. And if you set the save option, that means that the driver will wait until MongoDB has acknowledged that it has received and applied it has received the instruction to update things in memory. Now, you can also set it as an option on the connection object, which means for everything that you do with MongoDB, with that MongoDB connection, it will then use save updates. It's also very likely that from the next driver versions upwards, operations will be saved by default, because I think that has to be done. But again, yeah. And if you do this, you actually get an exception that will give you an error message. It says duplicate key, error index. It tells you the field name, and it tells you which value the duplicate value is, which just falls off the screen here. Now, there's a few different strengths of how you can do save updates. The first one is that I just showed on the previous slide, is that you can confirm a change is being recorded in memory, which you do with the option save equals true. The second one should work, but doesn't yet. The third one says, if you set the options fsync is true, that means when you send the object, it will then apply this in memory, and it will also make sure that the update gets flushed to disk. This is something that you don't really want to use, because it makes things really, really slow. There is better ways of getting around the durability of your updates by using two servers, using a replica set. In case you don't want to do that, you can go for either committing to disk, making sure that works by setting fsync to true, or when we add it to the driver, you can also confirm the inclusion in the journal by setting j equals true. In case you do have replicas, it's also possible for you to tell the driver to how many documents, no, how many replicas the update or insert has to be replicated before it returns true, which you do with W2. It also has a value called, what's the name? I can't remember the word now. I know exactly what I want to say, but majority, that's what it is. So you can also set W to majority, which makes sure that it is always going to be replicated to more than 50% of all your replica sets. And by that time, you're pretty much certain that the write will never get lost. Queries are again done with JSON objects, again PHP 5.4 syntax here. So what we're doing here is we have a query, we find all the documents that have a title field. So there is often the queries are done with field name and value, but there's a few extra things here as well that you can do. Like you have query operators, in this case we have exists. But there's also something like greater than and equals, and all those things are also part of it. So if you want to query for all documents where the title exists, then you set exists equals true. Now, what this document, actually when you run this method, the find method here, it actually returns you a cursor. It doesn't instantly do a query for you, because it is possible to set some other options still on the cursor, which my next slide will show you. So what you get back is you get a Mongo cursor object, which works as an iterator in PHP. So you can use for each on this iterator object. And at that moment, the first time it needs to pull out data, it will run the query for it. So if we do lots and lots of stuff in between here, the query only gets started when you actually for each over the cursor. Out of that, you get documents again, which are key values. Again, the keys are always going to be either, they're always going to be string, whereas the value can be whatever you put in there, of course. So in this case, title is a field with a string value, and tags is an array that we join with a comma in between. Somebody got really excited at stamp X there. Alright, so I already mentioned that there's some other operators you can do on the cursor, so you can set limit and skip, for example. There's also sort, that allows you to sort the result set, ascending, descending with multiple fields and things like that. It's pretty much how you would do this in SQL. So that also means that if you set limit and skip on the cursor like this, if find would already run a query, then the sorting, limit, and skip would have to be done on the client side. So this is why we would only execute a query when you start using the data that the query is supposed to find. So that's why we have sort, limit, and skip here. And that returns then a bunch of IDs. So the ID, _ID field is a Mongo object, but it implements a toString handler. That's why it's not showing object or can't convert object to string there. It just shows you the ID in that case. But you can't do queries with just this number. You have to wrap it in a MongoDB object, which can be a bit confusing at times. Now, there's a few other query operators that you can do. There's LT for less than equals, greater than equals. It's also not equal, exists, whether the field exists, modulo, which is, well, not sure how to explain modulo, but you can check values in a specific range. There's also a couple of logical operators, or by default every element of your query will be an AND query. But you can use OR, so one needs to match AND, but you need to nest that, otherwise it's by default there. There's also NOR, which is not OR and not. And those are just very basic sets. There's also a little bit more advanced ones. You can do tests with arrays, so whether field value fits in an array, or when it's not in there, or things like what the exact size of an array is and things like that. That's most often useful with either a value of 0 or 1 or things like that, because you can't test for the size of an array being greater than 5. And there's also LMatch, which is useful in case you have an embedded document and you need to match against two elements out of that nested array. Because if you wouldn't do that, it will just try to match against the whole document. I've used that as a slide, but quite difficult to explain. So a very simple example here with greater than or equals. I have insert two documents in MongoDB here. I have two circuses having elephants, or in this case I have performance. When I insert this, and then my query requirement is find circuses with 40 or more performers, which is going to be one document. So we translate this requirement to how we run a query. So I used find before. There's also something called find one, which will always return the first result only. So I'm running the queries where the performers field has a value that is larger than 40. Then to return only specific fields, you can use something called a projection. So we have the field name and the field performers we want to be returning in a document. By default, it will also always ask the ID field back. So actually, the requirement of our query is not reflected in the example, right? Because it will only always return one. So then when we run this, we get the result where you get the ID, the name, and the number of performers. All right. So updating documents goes with the update method. So again, we insert the name of an elephant in our elephants collection. And I can't pronounce the name. I've tried before and practiced on it, but I can't. So we insert a elephant in our database. Actually, I should mention that there's remove as well, which removes documents based on a query, or if you don't specify anything, it'll just delete everything in there. So that's basically your drop, which is a good idea in slides, but not if you actually do data. Well, you know what I mean. All right, so insert a document, and then we update based on a query. So update takes a query as the first argument, and then an update specification. The update specification is, if you just have field and values, that means it is going to be the new object that you're going to store. So if I would update this, then you get a document saying ID E42 and the name is both of. It's a different elephant, I suppose. You need to realize, though, that if you would do it in this example, where we say we have the name of the elephant, which is our query being based on, and we want to add a field saying age is 17, then this will actually not work, because the document that we find will be replaced with a new document. In this case, you will lose the name, because it's not part of the document that you're updating with. Now, there's of course ways around that, is by using a different kind of update specification. So again here, we insert a elephant, Dumbo in this case, and instead of replacing it with a whole new document here, we're calling set, and set sets the value of a field. So we do set, and we set the age to 17. And this then gets stored in the database. This example also shows you that, well, doesn't show you, but something I can tell you, is that MongoDB is peculiar about data types. So if you use a string saying 17, then you will only find it if you search for the string 17. You won't find it when you look for the number 17. So it's very important to make sure that the data types you use for inserting are the same as for querying. And that caught me out a few times using this. Also, an interesting thing about updates is that if you do an update without the criteria, it will also only update the first document and not subsequent ones. This is also something that caught me out when I started using MongoDB for a project, and it was because I wasn't aware of this. So what this does is we insert two documents, right, with two elephants' names. Again, the one I can't pronounce, and Denali, and both are age 17. So what I would expect it to happen is we find every elephant with an age of 17, and then inc for increment, which is a different operator than set, and the array, and we add one to it, increment the field age by 1. Now, if you would run this example, then you will see that only one of the elephants will get its age increase, which is the first one. So in order to avoid this, also the iterator to array, what it does is it iterates over the whole cursor and returns every row or every document in an array element in that case. So in order to get around this, you will have to set an option to update. So we have the criteria, the objects we want, or the documents we want to update. What to do with them is the update specification. We want to increase the age by 1. And then we set multiple to true to make sure that it is multiple elements, or multiple documents. Another interesting one is upsert, which is a combination of insert and update. So I have a very simple example here. First of all, I'm using drop on the collection, so to make sure I have an empty slate there. And I created a function called birthday, which accepts the collection as an argument, and then the name of the elephant. So the intention of this is that you find the document of the elephant, and then we increase the age by 1. And we set upsert to true. Now, the first time we run this, with this function call, the document doesn't exist yet, because we've just dropped the whole collection, right? But by using upsert, it means that if the document doesn't exist yet, we will create it. So what happens the first time, it runs an update, but we set upsert. So it updates on the criteria based on the name. And then we increase the age by 1. Because this document doesn't exist, it will take both the criteria as well as the update instruction and create a document out of this. So the first time we run this, it will create a new document in our collection with the field's name being Santon and the age being 1. Because if a field doesn't exist and you increase it, it just uses 1. And this is because of upsert. Again, another PHP 5.4 feature using the square brackets behind it. And when we run this, we get, as results, 1 and 2, because we increase from nothing to 1 and from 1 to 2. So there's a few document update modifiers. I've already shown you set and inc. There's also dec and unset. There's a whole bunch of them for arrays as well. I've already shown you inc, so I'll skip over this example. Then we get to something like indexes. Now, just like a relational database, MongoDB requires indexes to be fast, well, faster, at least. By default, there's always going to be an index in the ID field to make sure that an ID field lookup is fast. Indexes can be a one or multiple fields, and you have to specify the sort order as well. So the index already knows whether you want to sort ascending or descending. Now, it doesn't make so much of a difference because MongoDB is clever enough that if you do a sort on an index field, and the sort is the opposite way of what your index does, it knows how to reverse the index the other way around. There's only very few occasions where the sort order makes sense or makes a difference. In order to figure out where you actually need indexes, you have something called explain. Again, very similar to what a relational database does. So I have a very small example here. I, again, kill my collection of elephants. I ask 2 elephants in there, Jumbo and Tantor. And when I then run my find query, I run explain behind it. When you get this, the example shows, I know it extends way far to the bottom, but that's not the interesting information. The 3 interesting bits for now, or the 4 interesting things now, are the cursor tells you what type of index is being used for this query. So if it says B3 cursor, that means it's an index lookup, and it tells you which index is being used. Then tells you with nscanned how many documents have been evaluated to be able to give the result here. Because this is an index, it can look up the documents straight away. Nscanned object will skip over, and n is the number of documents being found. So in case you have an index, those numbers will be the same. Now, in this case, I have 3 elephants in my database, or in my collection, and I'm finding the elephant document by name. Now, we haven't created an index, so you would not expect this to give an index back. In that case, your cursor will be a basic cursor, and a basic cursor is the equivalent of a full table scan. Something you definitely want to avoid if you have lots of data that doesn't all fit in memory. So in this case, it shows you how many documents have been scanned, which is 3, the amount of documents in my database, and how many are returned. So MongoDB approaches indexes in quite an interesting way. If you have multiple indexes, it will actually use all of them at the same time, and the one that gives the result back first wins. Which means that if your dataset changes, then obviously it caches this value for a while, right? So after a certain amount of insert and update documents, it kills the cache, and then the next query will have multiple indexes competing for which one is fastest. Which is an interesting way. That means that the indexes, there's no query optimizer that has to do large amounts of data finding to figure out which index will be better. It will just run all of them, which I found an interesting way of doing this. So in order to create an index on the elephant name, we call something called EnsureIndex. MongoDB itself also supports create_index, but it's not been implemented in the PHP driver. EnsureIndex basically means create the index if it doesn't exist, and if it exists, just ignore it. And now when we run this example again, you'll see that we use a B3 cursor again with the name of the index, which is the names of the index are always going to be field name, underscore, and then store direction. If there's multiple, they'll be separated by underscores again. There's also something as a 2D index, which is very useful for finding pubs or other geospatial 2D indexes, mostly pubs. Really. And you do that by creating a 2D index. So instead of using 1 or -1 for the store direction, you use 2D as a string, which makes it a 2D index. And in this case, we're inserting 2 pubs very close to where I live, with L is my location field, and that accepts 2 values. And those values are not latitude and longitude, they are longitude and latitude. Which is really confusing if you're not aware of that. The only thing that matters in which order the values appear. If you call this field latitude and this one longitude, it will still pick this one as longitude and that one as latitude. So that's also a bit confusing. It doesn't care about the names of the fields, it's just the order that matters in. And there is no specific method for querying this geo 2D index. So in case a driver doesn't have a specific extra handler for this, you can basically call something called a command, and the command runs on the database. And each command will then have the name of the command. In this case, we're running a geonear query on our pubs collection. We specify the point where it's going to be near to, and then we set spherical as true. If you don't set spherical as true, it will do the it doesn't use a curved earth model, it uses a flat earth model. if it's important for you, you probably have to want to set this variable through. And this returns a result set, and a result set is going to be one document. It's because commands can only have one result. So it returns one document as a result, which means that those documents, because it can only return one and the document size is limited to 16 megabytes, it's limited in the amount of results that it can return. And this is why most of the commands will have a default limit built in about how many results they will return. You can override this, but you need to make sure that it doesn't get over the threshold of 16 megabytes, because then the query will fail and you won't get a result. So besides getting the results back itself, it also gives you lots of statistical information. In this case, we're not so interested in that, so we just loop over the results, and then we print the name of the pub and how far away it is. And it returns how far it is away in radians, so you have to multiply that by the diameter of the Earth. And this then shows you, again, two elements, and ordered by which one is closest, and it then shows you. This one is 0.36 kilometers, the other one is 0.83 kilometers. Okay, distinct is another command. So again, using the command syntax, we're using distinct as the command. Again, we're using the pubs collection. We want to create a distinct of the key being the city, and commands very often accept other parameters as well. So in this case, we only want to find every city that has a pub other than a Wetherspoons. So in this case, you'll get back a London and Manchester, because Coventry has a Wetherspoons only. It is very limited sets, of course. Right. So this is a very quick introduction to most of the simple things in MongoDB itself. There's a few interesting tools that can be used for monitoring and some simple administration. There's a tool called Genghis. Genghis is PHP myadmin for MongoDB. There is PHP moadmin, but please stay away from that. It is, to say it nicely, atrocious. But it sort of works as well. Genghis looks really pretty, and the only thing you have to do is drop one file in your document root, just like the apc.php thing, right? But other things. It's very simple to use, and it allows you to dive into which document you have in your database. I don't like GUIs. It's a personal preference. So if you install MongoDB, you'll also get a Mongo command line tool, which is very similar. It's equivalent to the MySQL command line tool, which allows you to do all kinds of cool things on the command line, which is my preference. But it can be a nice way to quickly check what's going on sometimes. There's also a tool called MMS, which is a hosted solution. So this is something that Tengen runs. In order to make use of this, you install a little agent on your server. The little agent sends statistical information to this hosted platform, and then you get cool graphs out of this, showing you lots of things about performance in MongoDB, how many queries you have, how much memory it uses, and a whole bunch of other statistical information that I can be talking about, but I'm running out of time for that. MMS is a free tool to use. The only thing you have to do is install like a little agent, and it works for one machine, but it also works if you have a large cluster as well. Creates even prettier graphics in that case. Yeah, I have to mention one thing about MongoDB has a conference coming up in June 20 with lots and lots of interesting things. I'm not quite sure what exactly will be there, but I was there last year, and there's lots of cool content there. It's going to be June 20th at the Mermaid Conference Center, which is Barbican somewhere, I think. I don't actually remember where it is. There's also a couple of user groups. There's one every 2 months near Barbican. There's going to be a new one in Reading. And there's something called office hours, which is every 2 weeks. It's basically 2 hours when people come to our not office and can ask questions. It's basically 2 hours of free consulting. That's my MongoDB user group slides. That's what I had so far. Are there any questions that you'd like me to answer? Yes, I think the microphone is on.
Yeah, you said that the document size is limited. How does it handle it if you put more data in it and it's just about to go over the threshold?
If you do an update that will push the document over the size, the update will fail. Which means that the update query that you'll do will get an exception, as long as you save updates on it, of course. But yeah, and then I think each of the specific errors that you can get by updating data returns a different exception code, so you can then some testing on it in your application as well. All right. That's one. Yeah, go ahead. I'll let you go.
You mentioned, I never used Mongo before, but you mentioned that it's made basically for that data set are now relational. The best example, one of the very good example comes in my mind is to store the sessions.
Yes.
Do you have any recommendation or do you have any example with your personal experience how to do that efficiently?
The only project I have used MongoDB, and we were using Memcache for sessions. Memcache is quite a lot lighter than MongoDB for this kind of things. However, another project that I've been very marginally involved with used the MongoDB for the sessions because they needed multiple machines with the sessions on. So they used the replication features of MongoDB to do the sessions, to be able to scale it up, really. So that you don't have to tie a specific machine to a different Memcache where you have to bottleneck because it can replicate and things like that. But that's basically what I've done with it. There's a question up front here.
The first chance I had to use a document database was using a graph database. I don't know if you've heard of those, but I guess the idea is that you get documents and then also relationships between documents. And I was just wondering if you could do that sort of thing with MongoDB and how people are doing that. Just for example, the simple example would be recording who's friends or who knows each other amongst a group of people. Okay,
so MongoDB is, as I mentioned, not a relational database. There's a few tricks that you can do to record relations, though. There's a data type I haven't shown you because don't use it very often. But basically, this is it's an array that you store, where it has the name of the collection and an ID. This is called a DB reference. But MongoDB itself doesn't do anything with that. Some of the drivers implement dereferencing through that. But this kind of thing is something you'll have to do in your client, because MongoDB is not a graph database. And if your data storage or querying requirements are very, very graph heavy, then I would probably look at a graph database instead.
Okay, thanks.
Anything else? Somebody in the back is good for his exercise. No. right here.
In some of your slides you had remove, and other ones you had drop. What's the difference?
Oh, remove is basically delete SQL-wise. It runs a query of documents that it will remove from the collection, whereas drop will just drop the collection. If you have remove without any arguments, it will be doing the same thing. But you can specify criteria.
One more question?
One question left. None left.
Notice with the query creation, you had sort of partially an OO interface with the into update, but then the actual parameters that you're passing in to the update are just array keys and values, for example, $GTE. But are any plans for sort of greater use of OO in terms of the way that you create the query?
I didn't catch it. Is there
any plans for greater use of OO in the way that you create the query? So instead of passing in array keys and values and sort of loose strings.
Well, at the moment already, instead of the array keys, you can do can pass an object, but that wouldn't be good for any special query requirements or update requirements. At the moment, there's nothing there that does that inside the driver itself. There's one or two projects that have a PHP layer on top of this. We are at the moment thinking about how we can help things like that to the drivers. But it is a bit tricky because there's so many languages that we're supporting, and we want to make this an experience that is the same for all of the drivers, which is going to be quite tricky because they all feel different to the native users of the language. So this is something that we're playing with and seeing how we can make that better. because in my opinion, we need to do something about the queries and update statements, because I find it sometimes a bit tricky with all the nested arrays and things like that.
I suppose it's up to the user land community to maybe build a layer on top of that.
At least for prototyping, that would be good, right? And if it seems like a really good prototype, then there's no reason why we can then put it in a driver and so on. But yes, thanks. All right, that's the last question, I think. I have a few more words. Is if you scan this QR code with your phone, nobody's getting out their phone. I spent effort in that. Come on, scan it. It will create a link. It will give you a link to my website where you can download the slides, where I have a bunch of resources with links to other specific things. It also has a direct link to Join In, where you can leave feedback for this talk. In case you don't want to do that, you can also just go to Join In and give me feedback. I hope this was a useful talk. If you have any questions, feel free to email me or send me something on Twitter, and I'll try to respond to that. So that's everything. Thank you very much. I hope it was useful, and enjoy the rest of the presentation.